We own a deli cart on campus that makes two types of sandwiches, single and double deckers. Single sandwiches cost $10 and double deckers cost $15. A single sandwich takes 3 pieces of turkey and a double decker takes 6 pieces of turkey. We have 60 pieces of turkey to be used and we can only make 16 sandwiches before we have to go to class. How many of each type of sandwich should we make to maximize our profit?
So we have two variables, our single sandwich and our double-decker sandwiches. So we're going to let x equal our single sandwich, and then y will be our double-decker.
So now that we have our variables, we are going to write our objective function. Our objective here is to make money, so we're going to say that our profit is equal to 10x plus 15y. Remember, x represents our single sandwiches, and those sell for $10. Y represents our double deckers, and those sell for $15. So when we add those together, that's going to be equal to our profit, and this is our objective function.
Constraints. The first thing that limits us is the amount of turkey we have. We only have 60 pieces of turkey, and we can use 3 to make the single sandwiches and then 6 to make the double-decker sandwiches. So together, the amount of turkey we use for the single and the double has to be less than or equal to 60. Our other constraint is the amount of sandwiches we can make. We can only make 16 before we have to go to class. So the amount of single plus double-decker sandwiches has to be less than or equal to 16. And those are our constraints.
Don't forget about our implied constraints. Since we can't make negative sandwiches, both x and y need to be greater than or equal to 0.
Now that we know our constraints, we're going to graph our two equations. First, we'll start with turkey. When x equals 0, y is going to equal 10. Now, when y equals 0, x is going to equal 20. And now that we have 2 points on our line, we can make a connecting. Next, we're going to do number of sandwiches. When x equals 0, y is going to equal 16. And when y equals 0, x is going to be 16. And then we can graph our y.
Since we have two inequalities, and they're both less than, we will shade below each line. So this is below the sandwich line, and this is below the turkey line. So then here is where they both intersect. So the reason we shaded this pink region where they both overlap is because we're going to have our 4 vertices here at 0, 10, 12, 4, 16, 0, and 0, 0. And we're going to need to plug in each of these points to see which combination of sandwiches will give us a maximum profit for the day. To explain a little further, the reason we had defined the double shaded region was because we have the 2 constraints and we need both of them to be fulfilled. So this area in pink is where they are both fulfilled. And at one of the vertices we'll find the maximum profit.
Now that we have our vertices, we can plug them back into our objective function to see which one will yield a maximum profit.
So remember that our objective function is the profit is going to be equal to $10 times however many single sandwiches we make plus $15 for however many double-deckers we make. And then the x is our single, the y is our double-decker. And so out of all the vertices, we can see that 12 of the single sandwiches and 4 of the double-decker yields the highest profit at $180. So remember that for this problem, we are trying to figure out the highest profit we could obtain if we sold single sandwiches for $10 and double-decker sandwiches for $15. Our constraints were the amount of turkey, we had 60 slices, and then the number of sandwiches we could make before going to class, and we had 16 slices. We graphed both of our functions, the turkey and the number of sandwiches, and we found where the constraints met in the middle, found all the vertices, and plugged them into the original profit equation. After plugging in all our numbers, we found that if we made 12 single sandwiches at $10 and 4 double-decker sandwiches at $15, we got our largest profit at $180.
Thanks and giggle.